All right, well, we're going to do some work on 3D trigonometry. I've got a question I'm going to do from the book, which may have been a bit challenging. Just a reminder about bearings. So we talk about true bearings or three-figure bearings. So here's our starting point in red. And if you have your point, let's call it O, for instance, original for origin, or O for 0, whatever you might want to think. We draw this kind of compass rose, we call it, kind of a cross through it with a north pointing generally to the top of the page. So obviously 90 degrees, and we should use three figures because it's called three-figure bearings. So 090 is due east, and then 180 is due south, and 270 is due west, and then you'd get back to north all the way up to 360, but then of course it goes back to 0. So 135 degrees true, for instance, is between 90 and 180. Now, I can also say on a bearings question like this, well, to show that it's 135, I know that 135 minus 90 is 45. So I could show on my diagram, well, 45 degrees sits in there like that. Now, let's say we've got a question like this one. What is the bearing of B from A? All right, so we've got our point A here. All the way over here, we've got our point A. Point B is down here. I know it's 25 degrees. Now, you draw your compass rose through and you say, all right, well, that's 25. We know that it's always measured clockwise, by the way, from north. You sort of imagine you're standing on this point A facing north. You're asking yourself, how much do I have to turn my body around in the clockwise direction to be facing towards B? Now that's 180 plus 25. So it's got to be 180 degrees plus 25. So that gives us a bearing of 205 degrees. Always three figures, although that one's not an issue. Now, if B is 50 kilometers away, so we'll put that figure in, 50 km, away from A, how far south of A is the point B? Now I'll change colors for a moment. So basically what we're asking, imagine if I put a right angle triangle in, and I know that's 50 and I know that's 25, and I'll complete the green triangle. I want to know this distance. That's what it's asking me. What's this distance? And we can do that with simple trigonometry. If you look at the angle 25, this side, which I've put a question mark on, which I might now just call X, is the adjacent side, and that's how far south B is. And then, of course, 50 is the hypotenuse. And so cos is what we're going to use. Cos 25 is equal to adjacent over hypotenuse, X over 25. And so X is equal to 25 cos 25. Multiplies that. And that's going to give us some sort of value in the realm of 25-ish. 25 times cos 25. Ooh, making sure that it is in degrees and not messing around with our calculators. 22.7 to one decimal place. Good practice, as I keep saying, is to write it to a few decimal places. So 658 equals 22.7, and that's kilometers to one decimal place. Nice and clearly marked there. All right, so that's the kind of fairly straightforward. The compass rose is the key for this. So here we go. Question 7 out of an exercise. And let's just, if you haven't done it, we can have a go. If you've done it and comfortable, we can move to the next thing. Two boats are observed from a lighthouse 350 meters above sea level. Boat X is on a bearing of 138 degrees true and at an angle of depression of 23 degrees. Boat Y is on a bearing of 228 degrees and at an angle of depression of 16. First thing is to draw a diagram. We need to make sure that you concentrate firstly on the, if you like, layout in 2 dimensions. As you look down on these, make sure that you're getting that right, and then we add in the height of the tower and the other details. So we've got point O, which is my starting point. I'm going to think of that as the base of my lighthouse. I'm going to get my pen. I'm going to put through this. A simplified compass rose is the official term, but just a compass rose is fine. Boat X is 138 degrees true. Now 138 minus 90 is equal to 48. So that means it's 48 degrees greater than 90 degrees. So if I put X over here somewhere, I'm going to connect them up because this angle needs to be 48 degrees. And that would give me a bearing of 138. Boat Y is at a bearing of 228. Now 228 was between 180 and 270. So it's got to be between this down south and this 270. So I think Y is going to be somewhere around here. That's my point Y. And I connect that up to my O, my starting point. And the question is 228. Now 228 minus 180 is equal to 48 as well. So that angle in here is 48 degrees. Now you may have picked up by now, but if you think about it, if this is 48, this in the right angle must be 42, which makes this angle a right angle. And that's important to be able to answer this question. We need that detail. Now, the next part of the question is going to ask us to find the distance between x, y. So I'm going to connect them with a dotted line. Next bit of information, I'm going to start working on 3 dimensions. So we've got to draw a tower. So I'm just going to draw a tower here, lighthouse, something that looks vaguely like a lighthouse on my point O. So we've got this kind of lighthouse thing up here. Now if I'm standing at the top, and that is 350 meters tall. All right, now what it says is if I'm standing at the top of this tower and I look down to point Y, the angle of depression, I'm going to connect them with a dotted line. The angle of depression is 16 degrees. Now I'm going to call the top of the tower A, just so I can refer to it easily. 16 degrees. Now, if the angle of depression from A down to Y is 16, then because of alternate angles, the angle of elevation from Y up to A, looking up, is going to be 16 degrees. Then the question also says that the angle of depression from A, the top of the tower, to X is 23 degrees. I'll just draw an angle in there like that. That would mean the same thing, that the angle of elevation from X to looking up to A is 23. And there you have my diagram. So now we want to find this distance here, XY. Now to do that, we need to consider that there are this height here. There's 2 sort of right angled triangles, XOA and YOA, and then we're going to find these 2 sides. So if I can find this side and this side, then I can use trigonometry because it's also a right angled triangle to find YX. Now here I've drawn AOX with the 23 degrees and the height of the tower is 350 meters. Now, using this, I can find the distance OX. So, I'm going to use tan because I'm looking for OX. Tan 23 is equal to 350. That's the opposite side over OX. OX is equal to 350 over tan 23, which is equal to, if we find what that is, here we go. So we have 350 over tan 23, and that's 824.548 meters. I'll keep it to 3 decimal places for the moment. Then the second triangle down here, we've got tan 16 is equal to 350, the opposite side, over OY. So OY is equal to 350 over tan 16. And we're going to have that to be equal to 350 over tan 16, and that's equal to 1,220.595. Right, so we've got those, that's meters. And we've got those two things. Now you could go ahead and find OX squared plus OY squared is equal to XY squared and solve that to the nearest meter, ... Once you know that, if I come back to the diagram, what we have is a situation where you have your right angled triangle, XOY, it's right angled, you know this side, like I've put a tick, you know that side, you know that side, and you know that side. To work out the bearing of y from x, you need to put a compass rose through x and think, how do I work out what this angle is? Well, that's using alternate angles. That's going to be 42 degrees. I can work out this angle inside the triangle. And then, so what you need is, once you know those two angles, I'll call that theta, the distance around from this is going to be a bearing. So that's going to be 360 minus 42 minus theta. And there we have, that's going to be part C, the bearing of y from x. So how about you give that a go to find out how to do it, and we're going to move on. I'll have another little thing for you to have a look at. All right, thanks.